Hi all, welcome to our YouTube channel. Today we are going to discuss about insertion of node at the front of the linked list. Okay, so here this is the node, new node. So we are trying to insert this node into that front of this linked list. Okay, so inserting node in the front of the single linked list. In this figure, we have four nodes already. So we will have to try to insert this node into that first part. Okay. Header is a pointer that point to that first node. This is the first node. The link part of this header had saved the value of the address of the first node. Okay. So we are trying to change that link part of the header address to the new node values, new node address field. Okay, so what I said is we have to change the address value in that header part. Okay, previously if we have not inserted the new node, the value of the header link part is the address of the first nodes. If we need to insert that new node at a friend, then the value of the header will change. The new value contains the address of the new node. Okay, the address of new node had saved into that link part of the header. Okay, so this is the algorithm. This is the algorithm for inserting node at the front of the singly linked list. Okay, so the algorithm insert front is used to insert the node at the front of the single linked list. The algorithm insert sort is the name of the algorithm. Insert front. Insert front sl is the name of the algorithm. Insert front. Okay, so our algorithm insert front, we have the inputs. Header is the pointer to the header node and x is the data of the node to be inserted, which means this is the new node, have the data x. Already we have a linked list. Okay, this is the header. The address of the first node is 1000, second node 1002, third node 1004. Okay, a node contains two parts, data and link. Here the data is 2, data 3, data 5. So the header will save 1000, which means the header will point to that first node. And then here in this address field of the first node contain the data 1002, that is the address of the second node. The link part of the second node contain the data 1004, that is the address of the third node. The link part of the third node contain null value, which means uh, that third node has not been pointing to any other nodes. Have not a node after that third node. Okay, so I will draw the link. This is our link list. Okay, so our aim is to insert a new node. This is our new node. I will draw the new node. This is our new node. Contain the data x. So we are trying to insert this new node into that front of the linked list. Okay. So after inserting, this is the first node, this is second node, this is third node, this is fourth node. Okay. Before inserting, this is first node, this is second node, this is third node. Okay. After inserting, the node position will change. The address of this new node is 1006. Okay. So we are trying to insert this node into the first locations. Okay. So what is the criteria for inserting a new node into that friend of the linked list? So we have to change the header value. Okay. This now before inserting, the value of the header is 1000. Okay. So after inserting, okay, I am discussing about the after insertion part. After inserting, this 1000 will change to 1006. this 1000 will change to 1006, which means the header will point to the first node. Okay, and that address field or link field of the this newly created node containing the value 1000, which means that node will point to first node. That node means this address field of the new node had been pointing to that first node, previous first node. Okay, after inserting the new node, this link have removed. Okay, so this is the after insertion part. So this is the first node, this is the first node, this is the second node, this is the third node, this is the fourth node. Okay, so after insertion, this is our linked list header containing the data 1006, and this is the new node containing the data x, address 1006. Okay, and this is the second node containing the data 2, this is the third node containing the data 3, this is the fourth node containing the data 5. Okay, so this address field of the first node containing the value 1000. Okay, and this will point to that second node. Okay, the address field of the second node containing the value 1002. Okay, 1000, 1002, 1004. This will point to this node. The address field of the third node containing the value 1004. This will point to this node. The address field of the fourth node containing the null value, which means there is no node after this fourth node. Okay, so this is the newly created node position 1, 2, 3, 4. Okay, previously this node have that uh, first positions before inserting this new node. After insertion, the node position will change. Okay, so today we are trying to study how to insert a new node into that linked list. Okay, the header value will change after inserting. Okay, the header will point to first node. So a data structure, a single linked list whose address of the starting node is known from the header. The output, a single linked list with the newly inserted node at the front of the list. This is the output. Okay, so you have to we have to mention the points on that about the algorithm in exams. So our algorithm name is insert front S. I will show the output. So this is the code. Here I had inserted the data, insert front 10, insert front at head 20, insert front head 30. These are the function I had called. First am cutting that code. First I had run the program, and then I had run the program, and only I had inserted the data 10. Okay, so the linked list containing the value only 10. Okay, and then again I am typing, I am inserting the value 20 after 10. Sorry, 12. Okay, so this 12 will, that 12 will goes to before 10. Okay, when I click on the run button, the 12 will place to before 10. Okay, so the first node contain the data 12, and the second node contain the data 10. Okay, again I am calling one new function, again I am calling the function insert at front, and will change the data 10 into 60. Okay, and I clicking that run button, then the newly created data 60 will save to had saved to that first locations. Okay, so this is a program that illustrate that insertion of node at the front. First I will explain the algorithm. After that we are going to explain that program. Okay, So this is the algorithm part. This is the pictorial representation for adding new node at the front. This is the newly created node. This is the new node. This is the new node. Okay. So we have to insert this new node into that first position of the linked list. Okay. The header first that pointed to that node inserted at the first. Okay. The address of the first node is 1000. Before inserting, the value of the header is 1000. Okay. After inserting, the value will change. The new node value is 1008. After inserting, this 1000 will changes into 1008. So what is the value of this header field? Link part of header field is 1008. Okay, which means that will point to that first newly created node. Okay, so I will explain the algorithm. So get node is a function is used to get a memory block of type node. Okay, using get node, we will get that nodes. Okay, have the data field and link field. So get a memory block of type node. We had used that get node function. This get node function, after calling the get node function, we got a newly created node having that two part data and link. If the value of new equal to null, which means the node has not been created, memory manager return a null on searching the memory bank, which means the memory or the node has not created. So print a memory underflow message, no insertion. Okay, and then exit, which means we have no memory. Then how we have to insert that? We will have to insert that node into that front of the linked list. We have no memory. Okay, we have no nodes. Okay, that's why we will not insert a node into that linked list. So our mission failed. Exit. Else means we have the memory. New not equal to null. Else means new not equal to null. That means memory is available and get a node from memory bank. Okay. So we got that memory. This is the newly created memory. 1008 is the address of the node, and then this is a newly created node. This data field, this field will save that data, and this field will save the address. Okay. So if we got that memory, then what we'll do? First change of pointer 1 as shown this figure. First, I am explaining that number 6. So first we have to change that link. Okay, new link equal to header link, which means new link. This is the new link field. Newly created node is new. This is new node. The name is new. Okay, and then I had changed it. This is a new link field. Okay, this is the new link field. Okay, the link part of this node. This part is used to save the address of the next node. Okay, then what is the value of header link? Header link is now before inserting the header link is the address of the first node. I am writing the address of first node is 1000. Address of second node is 1002. Address of third node is 1004. Address of fourth node is 1006. Okay. New node address 1008. Before inserting the header, the link part of the header contain 1000. Okay. Before inserting. So first we got the memory. Okay, that is a memory of the address 1008. Okay, so we are trying to insert that memory into that front of the linked list. What is the step number? I am now explaining the step number 6. I had changed new link equal to header link. What is the header link? This is the header link. Header part link 1000. HADER header link is 1000. Okay, header link is 1000. Okay, so first step, sixth step, I am trying to explain the steps. New link equal to header link. What is the header link? 1000. Okay, so the new link containing the data 1000 as a link part. Okay, so in that link field of that newly created node containing the data 1000, that means the newly created node will point to that first node. Okay, so this address field of the newly created node have the address of the first node. Okay, after updating the link, I had saved the value x to newly created node. Copy the data x to newly availed node, which means I am trying to save the data x into newly created nodes. Then how to add the data? New data equal to x. Okay, new data equal to x. That is the code for adding data or updating the newly created node data part. Data part. Okay, data part is used to save the data. Okay, and then after updating the data part, I had changed the header link equal to new, which means this 1000 will update. Okay, the 1000 had changed into 1008. The 1000, we have changed the 1000 into 1008, which means the header will point to first node. The header will point to first node. Okay, this first node, newly created node, will point to this node. That is a figure. Okay, and then end if, and then store. This is the if condition. At that ninth line, we had entered that if, and then last step is store. So this is the algorithm. On that algorithm, we had explained how to insert a node, newly created node, into the front of the linked list. The name of the node is new. The new node containing the data x and address of the first node. Previously, we have one linked list. That address of the that node is 1000. Okay. Now after insertion, this is the first node. Okay. Before insertion, this is the first node. After insertion, the head value will change into 1000 each. Okay, before insertion the head value is 1000. After insertion the head value is 1000 each. Okay, so you have to draw this figure on that exam and then write this algorithm and mention that get node is a function is used to get a memory block of type node. Get a memory block of type node. Okay, so we are moving to that code part. First, I had included that two header files, stdio.h and stdlib.h. After that, I had defined that structure. A structure node is a structure name. The node contain the structure contain two field data and a nest. Nest is the address field that will save that address of the second node. The nest is a pointer, and data part will save that data. So this is a function word insert at front. That function uh, have on that function we had mentioned that allocation of memory, allocate memory for new node. We had used a dynamic memory allocation MLO. Using MLO, we had created new node. Okay, if the new node not equal to null, then the insertion is possible. If new node equal to null, then no, there is no memory, then insertion is not possible. Insertion not possible. Okay. So here on that insert at front function, uh, if we got a memory, then assign the data to new node. New node data equal to new data, and then new node nest equal to star head, and star head equal to new node. We had discussed this or in this algorithm. Okay, I had mentioned how to update the values of header and newly created node address part, link part. address. Okay, so you have to write this algorithm. Okay, what we have discussed here is how to update the header field of the node if we added a new node in that front of the linked list. Okay, that part I had explained here. So you have to listen carefully and then do your program. And then uh, function print list is used to print the node data. Okay, function to print the linked list. We have created three linked list, three nodes in three nodes of linked list have the data 60, 12 and 10. Okay, so using this print list function we had printed the data. First is start node start temp equal to head, which means we had assigned a node that name is head. Okay, so that head name, the head address of the head has been pointed by the variable temp. While temp not equal to null, then which means temp contain data, and then using printf we had printed temp data. Okay, and then we had updated temp equal to temp nest. Okay, so using this loop we will print the entire linked list. Okay, here we have three nodes in the linked list. We had printed the three nodes. After that, using a printf function, print null at the end of the linked list, which means at the end the address part of the last node have null value. Okay, so I am moving to that a main function. On that main function, first I have declared start node star head equal to none. Okay, which means first before inserting a node the head value contain the null value. Okay, so this is the function for insert a node. Insert at front is a function that is used to insert a node at the front. Okay, on that function I had passed the two arguments star ampersand head and 10. Ampersand head is that address of the head. Okay, and that 10 is the data. And then uh, I had used two functions insert at front three times and insert at 10, 12 and 60. Okay, and then print linked list using that function I had called print list function, and then I had passed the head value. Okay, then using that head value I had printed that entire linked list. Okay, so what is the function print list? The print list is used to print that linked list. Okay, so struct node star temp equal to head. Here I am updating that value of temp equal to temp nest. Okay, so on that code line number 30 we will traverse entire linked list. Okay, after traversing on the each traverser, each iteration of the while loop, then we will print the data of the corresponding node. Okay, so here I had passed that head value on that function print list. Okay, on that function definition of insert at front, I had used two parameters struct node star star head and a into new data. Okay, so I am explaining why I am using that struct node star star. Here I am using two star star. Okay, take the address of the head pointer struct node star star head and add the new node data to be inserted. Create a new node with a given data and assign its next pointer to current head of the list. That's why I have used the two star. Update the head to point to new node. Okay. This print function, the print list function, iterate over the linked list and print the data of the each node until it reaches the end. When the nest is null, okay. So the output for the code above, if the linked list initially it is empty and we insert 10 uh, 16 12 at the front, the output will be 16 12 10. I had last called the 60. I had last inserted the data 60, then the first node contain the data 60. Okay, inserting at the front, resulting in the new element becoming the head and the previous head becoming the second element in the list. In the case of insertion at the front. In C, we had used double star. Head notation is used when you want to pass a pointer to pointer, okay, to function. When you want to pass a pointer to pointer to a function, and it is necessary when you need to modify the value of original pointer inside the function. Okay, so let's break down why star star head is used in the context of the single linked list. Why the struct node star star head is used? How you know? Why I had used the struct node star star head? Had you studied about a passing by reference, pass by value and pass by reference? In C, functions arguments are passed by value by default. This means that when you pass a pointer to function, the function receives a copy of a pointer, modify the copy that won't affect that original pointer. Okay, only we are passing that copy. To modify the original pointer, in this case, the head pointer of the list, the head pointer of the list, to modify the original pointer, in the case, the head pointer of the list, we need to pass the address of the pointer itself. This is done using the pointer to pointer. That's why I had used that node star star head. Struct node star star head. Okay. Modifying for modifying the head of the list. The head of the list of a pointer struct node star star head that points to the first node. Okay. If you just pass in head as a normal pointer, any modification to head inside the function would not affect that original head in the calling function. By passing star star head, a pointer to the head pointer, the function can directly modify the head of the list and reflect those changes outside the function. Okay, so that's why we had used that double star. The double star is a pointer to pointer. Okay, pointer to pointer. In C, double star head notation is used when you want to pass a pointer to a function. Okay, on that case we will use that double star. Okay, so we had inserted three nodes. The first node containing the data 60, and second node containing the data 12, and third node containing the data 10. Okay, I had run the program. Okay, so you have to write the program and mention the points on your notes. Okay, so today we had discussed how to insert a new node at the front of the linked list. So you have to write the algorithm, figure, and program on your notes. Okay, if you have any doubt, please write your doubts on the comment section and share this video to your friends. Okay, thank you. Thanks for watching.